All right, guys, after page 3, whew, am I ready for something that's a little bit easier? Page 4 in the review guide takes us back to energy diagrams, all right? And the first thing that it asks us to do is label our energy diagrams, okay? Which we know reactants always are at the beginning of the reaction, so they're always on the left. Products are always on the right, okay? This peak at the top is our transition state. Okay. What else? So we've got reactants, products, activation energy. So remember, activation energy is always from the reactants to the top. Okay. So in this case, our activation energy is going to be this. Okay. In this case, our activation energy is going to be this. Delta H, remember delta H is always from the reactants to the products. That helps us figure out if it's positive or negative. So in this first example, delta H is from the reactants to the products. It's going down, so it is a negative value. This one, again, still from the reactants all the way up to the products. Since it's going up, it's going to be a positive number. Let's see. And then endothermic, exothermic. So remember, when the energy of the products is lower than the energy of the reactants, that is when we have an exothermic reaction. And when the products are at a higher energy than the reactants, that is when we have an endothermic reaction. All right. So number 17 says, does each of the following represent an endo or an exothermic? So what we're looking at to figure these things out is where the energy is, and is it positive or negative? So remember, when the energy is on the product side, the right side of the reaction, that means we have an exothermic reaction. And when the energy, when the delta H is negative, when we just write delta H is negative, that is also exothermic. In this case, delta H is not negative, it's positive, so that makes this an endothermic reaction. Energy is being absorbed. And then energy is on the reactant side, again, endothermic. All right. Let's see. Ooh, balancing. Let's see if we can balance these. So let's see. We have 2 chromium, 1 chromium, 3 oxygen, 1 oxygen. So I'm going to do a 3. So that gives me 3 oxygen on each side. That gives me 3 magnesium and 2 chromium. So 1, 3, 3, 2. Let's see, letter B, silicon, 1, 2 oxygen here, 1 oxygen here. So let's see if I can do this. 2 oxygen, which now gives me 4 hydrogen. So I need 4 hydrogen. And that also gives me 4 fluorine. So 1, 4, 1, 2. Let's see, so arsenic is 4, arsenic is 4, sulfur is 6. So I'm going to start with a 6 here. Let's see, so arsenic is 4, sulfur is 6, sulfur is 6. Here we have 2 oxygen. Here we have 6 oxygen plus 12 oxygen is 18 oxygen, which means I need 9 O2s to make that balance. Let's see. This one's tricky, just a little, because we have nitrogens in 2 places. Okay, so don't let that mess you up when you're counting. Okay, so let's see. I need to have 4 hydrogen, so that tells me I have to put at least a 2 here. So let's see if I do that, how that gets me, So I have 2 oxygen and 2 oxygen is 4 oxygen. I only have 3 oxygen here. So I'm going to put a 2 here, but that changes my hydrogen. So let's go back. That's what whiteout is made for. So now I have 8 hydrogen. So let's put a 4 here. See if we get to the end. So now we have 2 plus 2 is 4 nitrogen. So I'm going to put a 2 here. So that's 4 nitrogen. Okay, so I've got 4 nitrogen on each side. I have 8 hydrogen. 4 times 2 is 8 hydrogen. Here I have 2 times 3 is 6 oxygen. Here I have 2 plus 4 is 6 oxygen. So our coefficients are going to be 2, 2, 1, 4. All right. Let's look at this one. So we have 3 carbon, 6 hydrogen. Now, if I put a 3 here, that gives me 6 hydrogen, but remember now I have an odd number of oxygen. Remember, so what we're going to do here for this reaction is we're just going to double that right off the bat. So 6 times 2 is 12 hydrogen. So I would need 2 of these. 2 times 3 is 6 carbon. So now I've got 6 carbon on each side, 12 hydrogen on each side. Over here I have 6 times 2 is 12 and 6, 18 oxygen, so I need a 9. So 2966. And finally, let's see. So I have 2 chlorine here, 1 chlorine here. I have 1 magnesium, 3 magnesium. So let's do that. Let's make this a 3. So now I have 3 magnesium on the left, 3 magnesium on the right. This gives me 3 times 2, so 6 chlorine. So I'm going to put a 6 here. Let's see. So now my chlorine's balanced, my magnesium's balanced. What about my hydrogen? I have 6 hydrogen here. So a 2 here gives me 6 hydrogen, which gives me 2 phosphates. So I'm good to go. All right. We are going to do this whole next page. So this will be 2 pages for us. So we're naming the compounds. Remember, when we're naming, we just put the first element, sodium. Chlorine, we change that ending to IDE, so ClO chloride. Okay. We flip over to page 5. Barium. Oxygen, so it's just barium oxide. Here, notice we have PO4. We should recognize that as a polyatomic ion. Okay, so magnesium, phosphate. All right, because PO4 is phosphate. Okay. This, we used to call this hydrogen monochloride, but now that we have done acids and bases, we would call this hydrochloric acid. Okay, hydro because it's not a polyatomic ion, it's just chlorine is the anion. All right, E is cesium hydroxide. That's a polyatomic ion. Ooh, this one, we have a transition metal. Okay, remember when we have transition metals, the thing that we have to do is we have to figure out what the Roman numeral is. So we have iron, NO3 is nitrate. Now, to figure out what the Roman numeral is here, okay, nitrate, remember nitrate is NO3 and it has a -1 charge. This is telling us we have 3 of those, okay? So we have 3 nitrates, which would be an overall -3 charge. So our iron has to have a +3 charge, okay? Now, sometimes you can just reverse crisscross that and it works, but I wanted to show you how to double check and make sure your charge is right. All right, G, calcium, and then Cn is a polyatomic ion, cyanide, so Cyanide, cyanide. Look at this, another acid. It starts with a hydrogen, it's an acid. This is a polyatomic ion. This is sulfate. Remember, 8 changes to ick. I ate icky ice cream and I got an itis. Remember, so 8. So this is just going to be sulfuric acid. If this was SO3, which would be sulfite, it would be sulfurous acid. Okay, so just a little review of that. And then finally, magnesium. ClO is hypochlorite, so this is just going to be magnesium hypochlorite. Okay, let's see. So now we need the formulas. Okay, so barium has a +2 charge. Chlorite, if you look on your polyatomic ion chart, is ClO2 -1. So this is going to be BaClO2 2 if we crisscross. All right. Magnesium has a +2 charge, bromine a -1, so that's going to be MgBr2. Phosphoric acid, so remember ick came from 8, right? So this would have been phosphate. Okay, so phosphate would be, PO4, which has a -3 charge. Okay, we have to put the hydrogen on there because it's an acid, so this is going to be H3PO4. Okay. Copper 2 nitrate. Remember, this Roman numeral tells us the charge, so this is going to be Cu. Nitrate is NO3 with a -1 charge, so NO3 2. Aluminum oxide. Aluminum makes a +3 ion, oxygen -2, so we end up with Al2O3. Hydrosulfuric acid. Remember, the hydro means that it's just the element, so just sulfur. Sulfur has a -2 charge, which means we're going to need 2 hydrogen to balance it, so H2S. Calcium is +2, hydroxide is OH -1, so CaOH2. And finally, beryllium is +2, sulfide is -2, so we end up with BeS because they cancel out. All right, I'm going to stop there, leave the math until the next video, but that is a quick look at page 4 and 5. I hope it's helpful, and I will see you soon.